this is it. This is a lecture in linear algebra, and I've put down the main topic for today, and I've put the system of equations that's going to be example to work with. Okay. What are we going to do with this equation? We're going to solve it. Today we use a method called elimination. It is a method which is widely used in the software to solve the equation, the systems of equations. If the elimination is successful, succeed, we will get the answer in a very efficient way. Okay, so when we complete the elimination, there is an obvious step called back substitution. It's very natural. Okay. This matrix actually represents the systems of the equations, and now we will do the steps to show you how to do the elimination. First of all, this is very important. The key numbers of this matrix. I put a box around it and write the name down, the pivot. This is the first pivot. Okay, so what does the elimination do? What's the first step of the elimination? Actually, we accept the first row, the first equation. It's okay. And we multiply the first equation with some multiplier and subtracted it from the second row. So what is appropriate multiplier? With what purpose? The purpose is decide the multiplier should be. Okay. So our purpose is knock out the x in the first equation. So let me ask you, what should be the multiplier should be? It's 3. Okay, the first row multiplied by 3 and knocked the 3 out. So this one is same, and 3 minus 3 1 plus 1 times 3 is 0, and 3 2's away from 8 is 2, and 3 1's away from 1 is minus 1. Okay, these guys didn't change. Okay, okay, you should say, wait a minute, what about the right-hand side of the equation? Okay, we put an actual column. B here. So what should we do to the actual column? Because we do the same. When I do the operation on the equation, we should do the same operation on both sides. So two keep the same, and we do the same thing. 3 2's away from 12. It should be 6 and 2. Okay, so what's the next step of elimination is what? It's kind of basic algorithm. Just do the recursive things. Okay, so the first step, we just knock out of the position of 2, 1, row 2, column 1. So we can use the 2, 1 to denote the first step. And what should we do next? Next for the next step of elimination, we do the same thing. First, we can see the second pivot there. What's our purpose? Our purpose is knock out of the 3, 2 position elements. So the multiplier should be 2. Okay, these all the same. 2, 1, 1, 0, 2, minus 1, 6. And 2 times second row get subtracted from the third row should be 0, 0, minus, oh, is it? Is it correct? 3, it should be 2, sorry. So, it should be 5, right? The 6, 6 it should be minus 10. Okay. This after elimination we got an up triangular matrix. We call it U. Okay. So so you see the elimination of. I think the next topic is back substitution. So back substitution is a very simple method to solve the equations in a reverse order. And if we get these equations, we can easily tell z equals minus 2, and we do the things upwards, back upwards, and 2y plus z is minus 2 plus 4 equals 6. Y should be maybe is 1, and we do the same thing. X could be 2. Good. Now this is back substitution. Now we know the elimination and back substitution. Okay. Let's stop here. Okay. See you next time.